All right. So, title is Subdividing a Segment in a Given Ratio, and the essential question we want to be able to answer and be able to do is how do you find the point on a directed line segment? And don't worry about the vocabulary there. We'll get to what that means in just a little bit. How do you find the point on a directed line segment that partitions the given segment in a given ratio? All right, so we're going to start here with this little explorer, and it says it takes just one number to specify an exact location on a number line. All right, so for this reason, a number line is sometimes called a one-dimensional coordinate system. You only need one number to come up with that location on a number line. All right, the coordinate plane, like what you see over there, all right, on the side of the classroom. All right, how many numbers does it take to figure out your location in the coordinate plane? How many numbers does that take? So again, how many numbers does it take to locate a position in the coordinate plane? If you want to if you pick a point, like right here, how many numbers do you need to know? Two. That's right. It's two. Okay, very good. So that would then be considered a two-dimensional coordinate system because you require two numbers to kind of locate yourself. And then if you think like in space, right? In space you have like a length, a width, and maybe like a depth. Okay, so that makes three numbers, right? And so we call space three-dimensional because it requires three different dimensions to kind of locate yourself, okay, in space. So anyway, back to this. So the mile markers on a straight stretch of highway turn that part of the highway into a one-dimensional coordinate system. I don't know if you guys ever noticed, if you're like driving on 70 or 270, if you look down to normally it's on the right-hand side of the road, there are these little mile marker signs. Okay, they're not super big. They're maybe like, I don't know, 6 inches tall, maybe a foot at most. But they count the number of miles as you're driving, and so this is helpful. Like if you break down or something like that, you can call, call someone and be like, oh yeah, I'm just past mile marker, 22 or whatever, so they can kind of have an idea of where you are on the road. Because otherwise, you're just like, I'm on this road and I'm kind of far away. That's. Of course, you guys have like GPS and stuff like that, so who knows what kind of powerful things you could do there. But anyway, the mile markers are there for that as well. So anyway, in this particular instance, imaginarily speaking, we're on a straight highway, and the exit for Arthur Avenue is at mile marker 14. Okay, and then the exit for Collingwood Road is a little bit further down the road at mile marker 44. The State Highway Administration plans to put an exit for another made-up street, Briar Street, at a point that is 2/3 of the distance from Arthur Avenue to Collingwood Road, and we're going to then figure that out. We're going to actually do that here. Okay, so we're going to follow the steps. All right. So, part A here, we're going to mark Arthur Avenue, point A, and Collingwood Road, point C, on the number line. All right. So, Arthur Avenue, that's going to be located at what coordinate? 14. Okay, yeah, that's right. That's the mile marker where it's located, right? So it's kind of like its coordinate, we'll say, 14. And so let's see here. So 10, 11, 12, 13, 14. Okay, and I'll call that point A for Arthur, I guess, or just because. That's very convenient. They named it Arthur Avenue. All right. And then Collingwood Road, where is that going to be? Looks like mile marker 44, right? So 41, 42, 43, 44. Point C. 44 there. Okay? So check. We did A. Done. All right? Letter B then. What is the distance from Arthur Avenue to Collingwood Road? And let's go to... let's see. So Adam, what's the distance from Arthur Avenue to Collingwood Road?
30 miles.
30? 30 miles? Mm-hmm. How'd you get that? Yeah, exactly. The coordinate for C minus the coordinate for A, excuse me, should give us that distance. So 30, or well, yeah, you can even put miles in there if you wanted to, because that's what we're using as our measuring here. Okay, the explanation I'm not going to worry too much about. I think the math kind of speaks for itself there, so I don't think we need too much explanation. Good. All right, so got that one done. So letter C then, how far will the Briar Street exit be from Arthur Avenue. So, Mary, how far
20.
will the Briar Street exit be from Arthur Avenue? How'd you get 20?
So Briar Street is 2/3 of the way from point A to point C, and so if you take 30 and multiply by 2/3, you'll get 20.
So yeah, we take that full distance, 30, right? The full distance from A to C is 30. Briar Street's not going to be 30 feet away, or 30 miles away, because that's going to put it right there at Collingwood Road. Briar Street is 2/3 of the way. Well, 2/3 of the way is 2/3 of 30, so 2/3 times 30 then, and that is in fact, 20, okay, 20 miles, okay. And so then, does that mean that I'm going to put my Briar Street exit right here on the coordinate for 20?
No.
But that's what it said. It just said 20 miles. That's
20
the...
miles
Uh,
the way.
right, it's 20 miles along the way, right? So it's not just 20 miles, the coordinate, it's 20 miles from point A, so what coordinate will that end up being then? 34 right there, Maria. So 31, 32, 33, 34, boom. There is where that Briar Street exit would be. So what is the mile marker number for Briar Street exit? It's going to be 34. Which is, I guess, what, 14 plus the 20 there. Okay? And so then it says plot and label. Well, we did that. All right. So now, so we said from A to B, right, Briar Street, it's 2/3 of the distance from A to C. What is the fraction of the distance from C to A? What fraction is it, like, what fraction is B from C to A? So if this is 2/3 the distance from going the other direction, what fraction would this one be? Yeah, it's going to be 1/3, 1/3 the distance, right? Okay, that's right. And so this breaks up our full distance here into a 1/3 piece here, and then the 2/3 piece right there. Okay. So that's going the other direction there. Good. Okay. I think we have a little bit more here. So yeah, there's a little bit more, and great we get to flip too. So it says, the Highway Administration also plans to put an exit for Dakota Lane. Oh, starts with a D. How clever. At a point that divides the highway from Arthur Avenue to Collingwood Road in a ratio of 2 to 3. What is the mile marker number for Dakota Lane, and why? Hint, it says, let the distance from Arthur Avenue to Dakota Lane be 2x, and let the distance from Dakota Lane to Collingwood Road be 3x. Interesting there, okay? So we want to break up our distance from Arthur to Collingwood in a ratio of 2 to 3. So that means that wherever we're going to put that letter D, that point D, it needs to have 2 parts on one side and then 3 of those same parts on the other side. So if we have 2 parts on one side and 3 parts on the other side, how many total parts are we talking about here? Yeah, we have 5 total parts. So we want to kind of break this up into 5 total parts, and then we want to go in 2 out of those 5 parts, because again, it says here, flipping back and forth, that that divides the highway from Arthur Avenue to Collingwood Road in a ratio of 2 to 3. So there'll be 2 parts on the left-hand side, 3 parts on the right-hand side. And so we want to do 2/5 of that total length. Okay, I'll write that up here, I guess. All right, 2 parts on one side, 3 parts on the other side. That's a total of 5 parts, and we want to go in those 2 parts there. So 2/5. 2/5 of what distance here? Well, the full distance. So yeah, Drew, what would that be?
30.
Yeah, 2/5 of 30. Do you know what that is? You can calculate for me? 12. Okay, so 2/5 times 30. Okay, that is, it is 12. Okay, for those of you that are like, how do you do that so fast, or how do you do fraction arithmetic, right? You can make the 30 as 30 over 1, when you multiply fractions, you multiply across the top, right? So 60, and multiply across the bottom, so 5, and then 60 divided by 5 is 12. Oops, and you can't see that because it's off the screen. There it is, okay? So that's a real quick fraction arithmetic there, review. Okay. So yeah, if we go in 12, so let's see, that's going to put us at 26, so 21, 22, 23, 24, 25, 26. There's where point D will be 2/5 of the way in. So from here to here is 2/5 of the full distance, and then from D to C, that's the 3/5 right there. And so that makes 2 parts here and 3 parts here. The ratio would be 2 to 3, 2 to 3. 2 parts are here, 3 parts are here, for a total of 5 parts. Okay. Questions on any of that? Not too shabby. All right. Maybe painful. All right, and then so part G was to label it, so we did that. Okay. All right, so we'll skip on then. We'll ignore those reflection questions, and we'll take a look here then at partitioning a segment in a 2-dimensional coordinate system. All right, so here's where we're finally going to understand what a directed line segment is. So a directed line segment is a segment between 2 points, A and B, with a specified direction, from A to B or from B to A. Okay? To partition a directed line segment is to divide it into 2 segments with a given ratio. So, for example 1 here, we're going to find the coordinates of the point P that divides the directed line segment from A to B in the given ratio. All right, so this one's kind of already done for us, but we'll take a look at it here. So, one way to do this, I think, you know, it's fairly painless, is that you plot your 2 points, A and B, all right, and then we're going to break up A and B. We're going to partition it, okay, so that where we put our point P, it'll have 3 parts on this side of point P and then 1 part on the other side of point P. Okay, so from A to P is going to be 3 parts, from P to B will be 1 part. All right. And so before we do that then, we want to find our total distance. But we are going to have some trouble here because it's a diagonal distance. Right? Got that diagonal distance there. So instead what we can do is count the rise and the run, okay, between our 2 points. So you can like actually count it, or here you can see that actually they subtract to find the total rise. So the rise from A to B is going to be the change in the y coordinates. So, oh, sorry, there's the change in the y coordinates. So 5 minus the -7 there gives us a rise of 12, right? And then the run here is the change in the x coordinates, right? We have 8 and then take away the -8 there, and so that's a run of 16. Okay, so that's the total rise and the total run. But of course, we don't want to go the total rise and the total run. We want to break it up in this ratio here. So, to maintain this ratio of 3 to 1, so wherever we put point P, we need to have 3 parts on the one side, 1 part on the other side. So that means how many total parts are we going to be dealing with here? 3 parts on one side, 1 part on the other side, so we'll have 4 total parts, right? And the distance from A to P has got to be 3 of those parts, so we want 3 over 4. That's our fraction there, okay, our ratio. 3 to 1, yes, it'll be 3 on one side, 1 on the other side, but then the fraction of the distance is 3/4 of the distance. So with that fraction then, we can do 3/4 of the run, so 3/4 of the 16 is 12. Okay, so if you kind of like, and then you do 3/4 of the rise, so 3/4 of 12 is 9, and so if we then go from point A, and we go run of 12, so we'll run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we'll rise 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, there's our point P that divides that segment there, the full segment AB, into 3 parts on one side, 1 part on the other side. Okay. So there's that. So let's actually do one here. Let's look at part B then. Okay, so there it is, done for us. Let's look at part B. So we're going to plot here. A, -4, 4. Okay. And B, 2, 1. All right. And then we'll connect the dots. Okay. And then now we want to find point P on here so that P breaks this segment from A to B into one part on this side and then two parts on this side. Okay, so P's got to be located, so we have one part on the PA side and two parts on the PB side. So how many total parts are we dealing with here then, Stephanie? 3. And again, since P has got to have one part on this side, that's going to be what fraction of the total distance then? Yeah, just 1/3, because we want to go from A to P is going to have one on the, from P to A is going to have one part, and then from P to B we'll have two parts. So we want to do 1/3. So we're going to do 1/3 this distance. Okay, good. All right, so let's see here. What is the rise from A to B there, Shannon? What's the rise? So from A to B is a rise of negative 1/2? Like, just like, well, I guess what I mean is, what's the change in the y coordinates? You go from A to B, what's the total change in the y coordinate? Negative 1/2. Oh, I see what you're saying. You're giving me the slope. Don't give me the slope. Just like, literally just, I just want the rise, is all I want. To get from A to B, I have to go rise how much? Yeah, I go down 3, right? So the rise, like, and we'll call that a -3, right? Because it's going down 3. And then what's the run there, Shannon? Yep, 6. And we'll say it's positive 6 because we're going to the right 6. Okay? So that's the total rise and the total run. But of course, I don't want the total rise. I want to do 1/3 of the total rise. So we'll do -3 times the 1/3 to give us then our coordinate for the point P. And so that's going to give us this -1 there. And then same thing for the run. I don't want to go the full run of 6. I want to go 1/3 of that to locate that point P. So 6 times 1/3 gives me then 2. So -1, 2, and did I make a mistake here? -4, 4. -1, 2. This should be on 1/3. Oh, duh. What am I doing? Sorry, I'm making a mistake here. There's the coordinate right there of point P. Sorry about that. I was thinking this is an x coordinate, that's a y coordinate. So that might be a mistake that you guys make, right? So remember, these are like run and rise. So we're going to run -1. Oh, no, that's rise. Rise, and that's a run. Okay, so the -1, that's the fraction of the rise we're going to do, so we'll go down 1 and then have a positive 2 run. Okay, and that gives us then where point P is. All right. So yeah, sorry about that. So again, -3 was the total run, total rise. We want 1/3 of that total rise. That gets us to the -1 rise. We're going to go just down 1. And then again, 6 is the total run. We want 1/3 of that to give us our point P, and so that gives us then just 2. So down 1, right 2, then gets us to the P right there. Okay, so there now, that point P breaks up this line segment AB into one part over here and 3 parts, or 2 parts over here, I should say. And you can kind of see it, right? Down 1, right 2, there's one part, and then down 1, right 2, down 1, right 2 gets us to B. So there's like 2 parts there and 1 part there. If you doubled this, you would get this length right here. Okay, so it works nicely. All right, questions on any of that? All right, now, alternatively here, all right, and let's see. We'll practice this here in a little bit. I'll give you guys some graph paper and stuff like that. I wish they had given us graphs here. I don't know why they didn't include those in there, unfortunately. But we're going to now look at another way to do this without the coordinate system. Okay, and so now we're just given kind of like AB, and it's on page 644. This is like AB, but we're not given, bless you, any sort of like coordinates or anything like that, but we want to break this up into a ratio of 2 to 1. Okay? So again, we want to locate a point P somewhere along here so that there's 2 parts from A to P and 1 part from P to B. Okay? So again, how many total parts are we talking about here then, Julia?
3.
Yeah, 3. Except what do I want my numerator to be this time?
2.
2/3, right, because we want 2 parts on this side. So we're going to go 2/3 of the distance there. So guess what? That's what we have our rulers for. We're not going to do this compass construction. That is like too much, okay? We're just going to do it with our rulers. So now, granted, this might not work out as perfectly as it would with a compass, but compasses don't always work out that great either. All right, so we're going to measure AB, and I get approximately... Well, actually, I'm going to call on someone to see what they say. So let's see here. So Patrick, what would you say your measurement is there for like AB? If you can read mine.
3.7.
Yep, that sounds good to me. About 3.7. Okay. And then what should we do with that distance there, Patrick, to then get where we... How can we use this information now to get point P? What should we do now?
Well, definitely. What did you say the ratio was on?
Ratio's got to be
Oh,
2 to 1, so that then results in a fraction of the total being 2/3, right? We want to go 2/3 of the total
So
distance.
then you just multiply the together.
Yep, so we'll go ahead and do that. So 3.7 times 2/3, and we get a decimal here, okay? And you guys okay to round here, so we'll say, Patrick, that's approximately what?
2.5.
Yep, sounds good to me. 2.5, okay? So then we'll just, with our straight edges here, we'll measure in 2.5. Voila. And there is where we will locate point P. Okay?
Is there a way to do inches?
You can use inches, yes. I like the centimeters because you can get a little more precise, because with the millimeters they're closer together, so I feel like it's just a little more precise, that's all. I like that. Okay, but if you feel more comfortable with inches, that's up to you. Okay? Alright, so let's try another one here then. We'll do B, and then that's pretty much it. Yeah, okay. So part B, let's see here. Alright, so let's see here. Our ratio we want to make is from 1 to 3. So then, Tanner, how many total parts are we talking about here?
You want 4?
Yeah, it's going to be out of 4. And then what's going to be our numerator here?
1.
Yeah, 1. Because we're going from A to B, so that means that A to P, that wherever P is going to be, A to P has to be 1 part, and then P to B has to be the 3 parts. So the total is going to be 4 parts, but then we want to go in 1/4 of that total. Okay, good. So let's see here. Next step, we should then do what here, Michael? We've got the 1/4. That's the total. That's the the fraction of the total distance we want to do. So now what should I do?
We should measure it to find out where to put the...
Yeah. Okay, so we'll measure it up here, and what does it look like AB is? That's pretty close to 5 centimeters, isn't it? That's pretty good. So we'll say 5 centimeters. And then what's the final step here, Michael, we got to do?
Multiply by the fraction.
That's right, multiply by 1/4. So what is it, like 1.75, I think? Oh, 1.25, goodness. Yeah, 1.25, thank you. So, again, just let's see here. So there's 1.1, 1.2. So to do 1.25, I'll go like halfway between the 1.2 and the 1.3. And right there we'll say. And that's where we'll put point P. Okay. And so we've partitioned the line segment, so now A to P is 1 part, and then if you were to do this A to P part 3 times, it would fit right in here. So basically A to P is 1/4. It's like 1/4 of the full distance there. Okay? Now, with that, if we go back to these coordinate ones, If you're a little uncomfortable with these, like this, like multiplying by the 1/3 kind of thing, which again, that will give us the precise answer. So this is the way to go. But if you want to like check yourself to see if you got it right, you can totally use a ruler here, right? So from A to B, for example, you know, I'll approximate that to be like, I don't know, like 2.8, or maybe even like 2.85. And then if I do 1/3 of 2.85, okay, I get at 0.95, which is like, you know, so halfway between 0.9 and 1. And so if I put my ruler down, sure enough, look where P ends up. Halfway between 0.9 and 1, right there. Okay, so that's an easy way to kind of check yourself to make sure you did it right. Okay, same deal here. If I go back up to this top one, if I measure the full distance there from A to B, I get about 4.2, I'll say. And again, if we want to do 3/4 of that, 3/4 times 4.2 is about 3.15. So if I measure out about 3.15, there's 3.1, and sure enough, point P is like right there between the two, the 0.1 and 0.2. Okay, so it's a good way to check yourself if you want to make sure you did it right. Okie dokie. All right. So then, I'm going to give you guys your assignment, and that's it for today, okay? That covers what we're going to be doing here. So I'll stop right there and let you